Welcome to the Explainer. Today, we are popping the hood on large language models. We're going to break down the actual mechanics of stochastic intelligence to unmask the predictive engine that is literally driving the modern AI revolution. So if you've ever found yourself wondering how these incredibly complex systems operate once you get past all the hype, well, you are absolutely in the right place. We're going to build a really clear, structured understanding of exactly what happens behind the scenes the second you hit enter on a prompt.
Okay, let's dive right into this. To really understand the mechanics here, we have to ground ourselves in a direct foundational truth, and it's this: AI doesn't actually know facts. I mean, it is so tempting to treat artificial intelligence like it's this omniscient digital encyclopedia, right? Like some kind of magical oracle holding all of human knowledge in a perfectly organized vault. But to truly grasp this technology and actually use it effectively, we really have to move past that assumption right away.
The prevailing myth out there is that these models operate as factual repositories. You ask a question, it looks up the answer. But the reality is so much more mechanical than that. They are actually just wildly sophisticated pattern recognition systems. They aren't looking up cold, hard facts in some massive database. Instead, they're analyzing unfathomable amounts of data to identify statistical relationships. Their entire goal, their foundational design, is simply to mimic human communication. It's not to act as some unassailable, verified source of truth.
So conceptually, this makes AI a guesser, not a knower. And I want you to keep that fundamental truth right at the forefront of your mind as we get into the actual mechanics today. Whenever you're interacting with these systems, you aren't talking to a researcher, you are talking to an incredibly advanced, mathematically driven guesser.
So how exactly does that guessing happen? Well, think of it like a continuous mathematical assembly line. First up, we have data input. This is where we feed the system just unbelievable massive amounts of training text. Next comes pattern extraction, which is where the model maps out the super intricate relationships between all of those words. And finally, you get probabilistic output. This is where it uses all those mapped relationships to basically guess what word should logically come next in a sequence.
If we zoom in on that pattern extraction phase for a second, the engine is analyzing those massive data sets to map relationships, and then it just outputs what is statistically plausible, meaning the system is always prioritizing linguistic patterns over objective truth. It optimizes for what mathematically sounds correct based on the structural rules of human language. It doesn't actually pause to verify if the statement it's making is an absolute objective fact. And this brings us to a really vital mechanism, and a bit of jargon: stochastic processing. Our sources define this as a probabilistic process where the exact same input can yield completely different answers during separate interactions. Because the AI relies on this probabilistic guessing, rather than just pulling a static fact off a shelf, its nature is inherently stochastic. You could literally type the exact same prompt 5 minutes apart and get entirely different results. It is a highly dynamic, totally unpredictable engine.
Now, this probabilistic guessing has a fascinating and, let's be honest, sometimes problematic side effect. Because the system is solely optimizing for what sounds statistically correct, it can and will confidently output totally fabricated information. We call these hallucinations. They are plausible-sounding statements that are entirely invented. The crazy thing is, the AI isn't actually lying to you. It has just successfully generated a linguistic pattern that happens to have absolutely zero basis in reality.
Which leads us to this really brilliant metaphor presented in the research: the mirror effect. See, when you type a prompt, the predictive engine is basically reassembling human language just to reflect your own query back to you. It uses its vast training data to bounce your inquiry structurally and linguistically right back in your direction. It perfectly mimics comprehension without actually understanding any of the underlying concepts.
So it is, in essence, the stochastic mirror. When you're interacting with an AI, you are definitely not talking to an omniscient being. You are just looking into a reflection of human language, reassembled completely on the fly by an engine that is making highly educated, statistical guesses about what words should logically follow one another.
Which leaves us with a pretty provocative question to chew on. If AI is merely a stochastic mirror, a predictive engine that prioritizes linguistic patterns over objective truth, who is really doing the thinking here? Are you actually relying on these tools for concrete knowledge, or are you just bouncing your own thoughts off a really sophisticated mathematical mirror? It's definitely something to reconsider the next time you type out a prompt. Thanks so much for joining me for this explainer, and remember to keep questioning the mechanics behind the curtain.